Hey, welcome back, you guys. Okay. So I think we'll do maybe one more example with the mean, median, and standard deviation also at the very end, just to give you guys one more last piece of practice. But what we want to do now is we want to look at the geometric average rates of return, or the geometric mean. Now, this specific average calculation, this is basically tied with the concept of calculating it's like a growth rate accumulation type of thing. Okay, so we're calculating average growth rates. Okay, that's the idea of looking at the geometric mean. So you have your data usually will come in like, from, actually, let's start with this. Let's start with this. Okay, let's say you have a bank account and you deposited $100. And at the end of the year, you had 110. How much did your bank account grow?
$10.
$10. And now the percent?
10.
10%. Okay. So the way we calculate that, right? Let's just set this up. Percentage change calculation. Okay. Typically is done new. By the way, sorry, I forget. This delta symbol, this triangle. This is actually read as delta. And in economics language, we use that to represent the word change. Okay, so percentage change is the new value minus the old value divided by the old value times 100. That's how we generate a percentage change. So in this case, 110 minus 100 over 100 times 100, we get 10%. Okay, so that's how we calculate a percentage change. Now, in calculating this, right, this is kind of a procedure, but there's a way to do this that's fairly quick. Like, let's do this now so that you kind of get an idea here of how this works. Okay. Now, let's say you deposited $90. Okay, and the bank says that it's going to grow at a rate of 20% in 1 year. Okay, how much do you have at the end of that first year?
$108.
Yes, you have $108. Okay, how do you do that? What's the procedure you guys follow?
90 times 0.2.
Well, what do you get when you do 90 times 0.2? Do you
18.
get?
Oh yeah, and then I added to the first number.
Yes. So there's two
Okay.
ways to do this, and that's kind of what I was getting at. Okay, so there's two ways to derive that answer. The first way is basically the one we do in our head, okay, the most common one, which is one, we take the actual value and we multiply it by the decimal of the percentage. Then we take that, again, our initial dollar amount, and add the answer from part one. This is a two-step process. There's a one-step process that we're going to use in the equation for the geometric mean. Right, so the second is a one-step process. Do you know how you can simplify this two-step process? What you can do? Okay, so this 90 here, we can kind of embed that straight back into that first equation. And what we can do is we can just do 90. Instead of doing this 0.2, what we can tell the equation is, look, take 90 and keep it there, but also add 20%. And to do that, you simply do 90 times 1.2, because that one holds the 90, and then you add the other 18%, so you can get to 108 directly. okay? This function here, 1.2, we could call that almost like the factor of change. Or actually, let's do it this way, sorry. It's going to be called the growth factor. 1 plus, to write it as an equation, it's 1 plus the rate of growth. Okay, so R is your rate of growth, or interest rate in this case. So this is how you generate that growth factor. It's just 1 plus R. Or R, of course, has to be in decimal form. Okay. So anytime we do this, typically this two-step process in our head is easier than multiplying with a decimal, basically 1 point something. It can be more, and mentally it's a little bit more challenging. The one thing is, I know the calculator can mislead on this, because in the calculator or on your phone particularly, you could just do 90 plus 20% and then it yields the correct answer. That could lead to lots of issues if you don't understand that the calculator, in fact, is actually doing that procedure. Okay, or this two-step procedure. So let's have a look here at the geometric rate of growth. What I want to add first is to show you guys the equation. So the geometric rate of growth, it's written as GM, usually in statistics books. Finance can use GAR, geometric average return, as well. Okay, so both of these are correct ways to state this. And the equation, if you look in your textbook, in the ebook, it's not a complete equation. They've modified it to actually improve it finally, but it's not a great equation. So let's rewrite this equation where it makes sense. So the geometric mean is, I'll write it two ways for you guys, is the product, 1 plus x1, where x1 is actually the rate of growth. This could be substituted with R, okay? In finance, we would use R. In statistics, they use X because it's like all of the other calculations. So this could be a rate of return and could also be R instead of X. So 1 plus x1 times 1 plus x2, 1 plus x3, say 1 plus x4, 1 plus xn. Okay, so there's n periods. And you would take the, I didn't leave myself enough space. Let's do this. N. Oh my Lord. Okay. So then you take this, okay, and you're going to raise it to the 1 over n. N is going to be the number of periods of compounding. Okay, so this is number of periods, we could say, in our sample of compounding. And then what you're going to do is you're going to subtract 1 from that. Okay, and then multiply it, subtract 1 and multiply it by 100. Okay, that's kind of the procedure. So you're going to take each growth factor, right? You're going to add 1, multiply them across, and take the nth root, basically. Okay, so this is one way of writing it. The textbook writes it this way. They have the nth root, 1 plus x1 times 1 plus x2, 1 plus x n, and then minus 1 times 100. The problem with their equation is they actually didn't even state that you subtract 1 and multiply it by 100. It's like you're supposed to know. It's written later on when you look at the details of the problem, but typically they don't have it. For some reason, they didn't have it written there. I can't remember if the new version adjusted that or not, but that could, of course, become kind of confusing, but these are effectively the same thing. One is just you take it to the power of 1 over n, and the other you take the nth root, which in fact is the same mathematical operation. Okay, so what we're going to do is this. Okay, we're going to look at calculating the average annual return for the S&P 500. I don't know what just happened. Okay, the average annual return for the S&P 500, to get what that is, and this is just, I think this is, years, 2017, 2018, up to August 2023. And then we're going to do the same thing for Apple stock prices. Okay, so we're going to set this up in this procedure. Now, this procedure is not entirely that necessary, but I think as an initial step, it's pretty good to kind of calculate the growth factor and then put it into the equation itself. So remember, this whole part right there, 1 plus R1, that's going to be your growth factor. Okay, so let's start with this first one. I know I've filled in a few of them. This is for the S&P. So the first year, the average return, or the return for the first year, was 19.42% for that year. First thing we do is we're going to convert it to a decimal to turn it into a growth rate. And so that's going to be 1942 divided by 100, which becomes 0.1942. Then you're going to add it to 1. And you always start with 1 plus the growth rate. Okay, so the first growth rate is going to be 1.1942. So if you had invested $100 into the S&P 500 at the start of 2017, at the end of it, you would have $119.42. Okay, now next year, there was a loss of 6.24. Now, one thing that's missing here is the little negative sign. So we would take negative 6.24 divided by 100, and you'll see it becomes negative 0.0624. Now, again, 1 plus, but this is important, that negative has to be there, the negative 0.0624. And that means at the end of that period, you would have, the growth rate for that period would be 0.9376. So notice it's less than 1. So it shrank. Okay, so whatever that value was at the end of that first year, it's going to shrink. Let me show you guys what that means in actual dollar amounts. So let's say this is your actual dollars. So you started off with $100, okay, in year 0. In year 1, that investment grew 19.42%. So the growth factor was 1.1942. So just to write it out, it would look like this. So at the end of that first year, you would feel like I had to update this good notes, and I feel like something changed about it and it's just not performing the same way it did. And I'm a little confused by it. Okay, so this is how much you would have in year 1. But now the next year, we lost 6%. So now you would take, not 100, but you would start with this value. You would do 119.42 times, here this growth factor, this 0.936, accounts for the loss of the 6.24%. And how much would you have at the end of year 2? So 119.42 times 0.9376.
$111.97.
101.97. Perfect. So that's how much you have at the end of year 2. Okay, so now what we're going to do is we're going to go through the rest of this growth rates. And then what we're going to calculate at the end is you're going to tell me how much you end up with at the end of those whatever number of years we have. And then we'll calculate the geometric mean after that. So let's go through this. Convert each of these into growth factors. And then each time we're going to change the amount of money that we have in our account in order to calculate how much we have at the end of that period. Okay, so what you're going to find is if you invested $100 in the beginning of 2017, how much money you have in August 31st, 2023. Okay, that's what you're going to calculate. And the growth rates for each. Okay, take 3 minutes. Go for it. By the way, this is the most commonly missed questions, is the ones on geometric rates of growth. Okay, what's the growth rate for that second one? I mean, the third one, 28%. This becomes 0.2881. What's the growth factor?
1.2881.
Correct. And then how much money would we have at the end of that period?
Would it be 111.97?
That's what we had in the previous, right?
Right.
So what do we have? Oh, you were telling me the steps.
Yeah, sorry about that.
Yes, no, that's fine, that's fine. I didn't.
So
Oh,
the total is 144.22.
144.22. I'm just gonna fix that because my own writing makes no sense to me. Okay, let me zoom in. 111.97 times 1.2881. We get, what was it one more time?
44.22.
122. Perfect. Okay, let's go to the next period. So next period, it grew 16%, 16.26. So 0.1626. What's the growth factor?
$1.1626.
Okay, perfect. So let's see, we have 144.22 times 1.626. How much money do we have at the end of that period?
167.67.
Okay, next year, we have 26.89% growth. Right, this one is negative. Oh, I just did the wrong thing. 0.2689 minus 0.1944, 0.1761. So this growth is, of course, that's fine because you don't have to subtract. And then what's this one? What's the growth factor for negative 19.44?
0.8056.
Yep. And then the last one will be 1.7, 1.17. Okay, so now let's see how much money we have at the end of the period. So here we ended with 167.67, 1.2689. How much money do we have at the end of that period?
212 and 0.77.
Okay, and then next one, 212.77. We lost 19%. How much money do we have here?
$171.40.
Okay, and finally, in the last year, we grew 17%. So how much money do we have at the end of that?
201.60.
Okay, perfect. So at the end of this 1, 2, 3, 4, 5, 6, 7 period progression, we went from $100 to $201.60. So overall, we actually doubled our money in that time period. Okay, so if you invested 1,000, you'd have 2,001. Okay, or 2010, etc. So you're basically doubling. In this case, you doubled our investment during that 8-year or 8 period time. Now, this gives us the overall return. Okay, now we want to know what is the average return per year. And to do that, we're going to plug in our growth rates into our geometric mean calculation. Okay, so again, here we have how many periods? We have 1, 2, 3, 4, 5, 6, 7. So it's going to be the 7th root. Okay, and then we have the first growth rate, the 1.19, the second one, 0.1937. 1.2881. Let's fill in the rest. 1.626 times 1.2689. Wow, this is not going to work out. Times 0.8056, 1.1761. Oh, there we go. It worked out. Okay, so all you're going to do is get the product of that. I think that's a good first step. Just multiply all of those. And either you can take the 7th root in your calculator, or you could use like the raise feature, the caret feature, and then put parentheses and do 1 divided by 7 to get the 7th root. Then you'll subtract 1 and multiply by 100. But first, just give me this component, the seventh root of the product of all those numbers. And that's going to tell us the average rate of growth in the market for that period. What do we get? What's the product? Seventh root of that product.
I don't know if my calculations are correct
Mhm.
because I didn't get to double check it, but negative 98.99.
What did you do?
I did that. I just plugged it into my calculator, but sometimes my calculator, like, I don't know. So I don't know if I did it wrong.
Let's do this. Let's make it easier. Just multiply just these numbers. Just give me that number without the root.
I got 2.81.
Without the root, right? Just the multiplication?
Yeah, just the multiplication.
Okay, 2.21?
2.81.
Okay. So now what you're going to do is you're going to take this number and just do this. Raise it to the
2.81, sorry.
2.81? Okay.
Yes, sorry.
I think you said that. I just didn't hear it. 2.81. Okay. And you're going to raise it to the 1/7. It depends on what calculator you're using, the operation you would do for this. But effectively, you could even, like, if you used your, I mean, use a different calculator, but if you have your phone, what you would do is type in that 2.81, and then you would do the little, where is it? The X to the Y, and then you would do parentheses 1/7. And what do we get?
$1.15.
The 1.159?
Yes.
Yeah.
1.159.
1.159. Okay, that would be it. Now, basically from there, we're gonna subtract 1. So we're left with 0.159. And then to convert it back into a percent, we're gonna multiply it by 100. And what this is gonna tell us is that the average growth per, like, over the 7 years is 15.9% per year. Oh, that's what it tells us. Okay, so notice what this equation does. You take the seventh root, right, of that product, you subtract 1 to basically undo that step where you added 1, and then you multiply by 100 to undo this converting to decimal step. And then you get back to an actual rate of return at that point. Okay, so the annual growth is 15.9%, the average annual growth. Okay, so this is average annual growth. Now, it's not the total growth. The total growth was 100%, right? From period 0 to the last period here. But if we were to divide that by per year calculation, it would be 15.9%. Now, what's different about this than calculating just general averages is that the geometric average return takes into consideration compounding interest, okay, which is a key identifying factor for all financial transactions. And this takes that into account, okay? Does this make sense? Let's try one more just so we can feel confident. I want you guys to now do the same thing, but with Apple. Okay? You're going to do the same thing with Apple returns. I want you guys to calculate the average return, the geometric average return, and also how much money you would have at the end of 7 periods if you invested $100 in period 0. Okay, so those are your 2 tasks. I'll give you guys, let's see, what do you guys want? What do you want? Let's see, maybe so you guys can see it. Is this visible for you guys? Clear? Yeah, okay. I want you guys to now do the same thing, but I want you to do it for Apple. Okay, here's your data. Follow the steps here. Okay, I'm gonna give you guys like, let's see, 5 to 10 minutes. Let's say 7 minutes and see how far you get. Okay, again, feel free to talk amongst each other. I'll set a timer so that you guys have 7 minutes to complete this. It's okay if it's not complete, just so we have some time. All right, have fun. And feel free to ask questions in the chat if you are confused. Now I can answer them now. All right, how are we proceeding? Um, see if I can move this so we could work on it. There we go. Okay. So here's our data. What's the growth factor for each of these? What's the growth factor for the first period? I'm just skipping this step, so just do this one. That's your growth factor. What's the growth factor for the first year?
1.4611.
Yep. What's the growth factor for the second year?
0.9321.
Okay. Third year.
Um, 1.8616.
Okay. Fourth year.
1.8075.
Next year.
1.3382.
And then what about this sixth year?
0.7317.
Okay. And then we have 1.4521. Okay. I want you guys just go back here, and I want us to look here, comparing Apple and the S&P 500. Notice how they move, right? Notice both tend to increase in the same periods and decrease in the same periods. Well, primarily one of the reasons is that the S&P 500 includes Apple stock. That's a pretty big component of the S&P 500. But notice every time it fluctuates, for the most part, Apple fluctuates more in either direction than the S&P 500. It's more sensitive to fluctuations. So now let's see what that means. We have our growth factors. So does anyone have how much money we have at the end of the period? If we invested $100, how much would we have at the end of 7 periods in Apple?
151.083.
I'm sorry?
651.083.
651.083. Confirmations? You guys want to go step by step one more time? Yeah, you confirming? Okay. Sebastian, yeah, Sebastian's confirming. Okay. Anyone want me to go through step by step one more time to see where we are? Step by step. Let's just do it. Okay. So going through this step by step. First year, you guys might need to help me though, just so it doesn't take forever. First year, we grew 146, so that's 100 times 1.4611. So we have 146.11 at the end of the first year. Second year, we lost some. How much money do we have at the end of the second year?
$136.18.
Okay, then we have 136.18 and it grew 86%, almost doubling. How much do we have at the end of the third year?
253.51.
Okay, then we go another, so 253.51 times another 80% growth. How much do we have at the end of that year?
458.21.
Okay, then we have 458.21 times 1.3382. How much do we have at the end of that year?
613.17.
Okay, then we lost some. How much do we have at the end of that year?
448.65.
448.65?
Yes.
Okay, and then finally it grew 45% in the last year. 65. So we have
651.48.
there we go. So this is our, we started with 100 and we end up with 651. The growth was over 600. Well, it grew by a factor of 6.51. So about 650% growth. Okay, so massive, sorry, 500 something percent growth. So it's a massive amount of growth here that we've had, right? The S&P just doubled, but this one increased our money more than sixfold, basically 6.5 fold. Now, what was the average growth per year, our geometric mean? Again, we have 1.4611 times 0.9321 times 1.8616 times. I'm never gonna get these 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 straight. Let's do it this way. Okay. Okay, and we're gonna take that to the 1/7. And what is that equal to? Let's start with that first. The product of those numbers in the 7th root.
I don't know if I calculated correctly, but I got 1.478.
478. Yeah, perfect. And so then we take, and did you take the root, the 7th root, right? Yeah, perfect. So then we're going to subtract 1 and we get 478. And then we're going to take that and multiply it by 100. And we get 47.8%. And that's your average growth per year. Okay. All right. So I want just a quick thing here for you guys. So this is going to be growth rate and growth factor. And this is just some, like, just special ones. So if something grows 100%, it grows by a factor of 1, right? Plus 100% as a decimal is 1. So it grows by a factor of 2. Okay. If something grows 200%, right, it grows by a factor of 3. Okay. And if something grows 300%, it grows by a factor of 4. Okay, just sometimes I could see people get confused about this in terms of the growth factor. And the actual percentage increase, sometimes they see it just as the same number, but it's not. So if something doubles, right, that means it's growing 100%. That means it's factors by 2. If something triples, it's growing by a factor of 200%. Quadruples, it's growing by a factor of 300%. I know it's like a kind of a mismatch there, but that's just a little bit of guidance for you guys. Oh, I had the data there. Is this clear? The steps for this? Just take your time. This is the most common mistakes here are just entry mistakes. Okay, just the one I would pay most attention to is any negatives. That's usually the biggest offset issue, is sometimes if you enter it as a positive, then it just throws everything off. So just be really careful with the negative numbers there. All right, there's one last component, and that is the geometric growth rate over time, where basically you don't have percentages like intermediate percentage changes. All you have is the value at the end of the period and the value at the start. Not percentages, but actual numbers, dollars, etc. And you take it to the nth root and then -1 times 100. So here's an example. In 1996, 40 million taxpayers in the US filed their individual tax return electronically. By 2015, the number was 241 million. What was the geometric mean annual increase? So the new value at the end of the period, there's our numerator. The value at the start of the period, that's our denominator. 96, from 1996 to 2015, that's 19 years. So you would just do 2015 minus 1996. So you take the 19th root, or you raise it to the 1/19, -1 times 100. What's the annual growth of people that do their taxes electronically? What do we get?
9.88%.
Yep, 9.88%. Perfect. Per year. And the thing with this is we don't know what the growth rates were, right? In one year, it could have been 30%, and in one year, it could have been -2%. And we don't know, but we just know if we just take the full amount and just divide it up equally across time, it will be growing at 9.8% per year. And let's just do this last one here, the Consumer Price Index. This is basically the CPI is what we use to calculate price growth or inflation. And so here we have the price index was in 1999, the price index was 220.3, and September 2023, which was last year, was 305.69. I want to know, what was the annual inflation every period during that time? So to do that, again, geometric mean is how many time periods between 1999 and 2023? Just do 2023 minus 1999. What's that?
24.
24 periods. The ending value was 305.69, and the starting is 220.3. I don't know why I put times there. There we go. And then -1 times 100. What's the average rate of inflation per year? But we know it wasn't consistent, but we'll discuss that in a second. What's our inflation rate?
$1.37.
I didn't get that. Can we confirm?
That's what I got, but I
You
could have
did?
done it wrong.
Let me check it. I may have done it wrong. So 305, 220, 24th root. Yeah, that's right. 1.37. Perfect. Percent per year. Okay, so that would be across 24 years. Well, we know mostly it was probably around 2% a year, and then it really picked up in 2021 until 2023. That was where we had a little bit higher rates of growth. But that's basically the two types of geometric means that we'll be looking at. The weighted mean, I want you guys just to watch that video for the weighted mean, and it'll walk you through it. I'm not too fussed about that one. Okay, so I think that pretty much covers everything I wanted to cover with you guys. Now, tomorrow, actually, there's, you guys saw my announcement for tutoring. I would highly recommend starting